Alright, so what we're going to do now is our last, not really a tutorial, it's kind of like a walkthrough. And I'm going to talk about threads and background threads and services, which was our last topic actually for this class. And what we got going on here is these two lectures here. It's called Multi-Thread Lecture Tutorial 1, Multi-Thread Lecture Tutorial 2, and then the Multi-Thread Solution. Download all three of these. We'll look at the solution. I'll talk about the concepts. What I'm going to do is kind of orient you to the thread concept. We looked at it in the last part of one of the tutorials we did out of the textbook, the Android textbook tutorials. That's not a bad source either for preparing for the final. All the stuff that we're going to go over, it's not API related either. No questions about it because we didn't look at the differences between any of the APIs anyway. In fact, most people don't even care about the differences. What we cared about was actually just getting it to work. So, but long story short, no questions about APIs on that exam. So, all right, so leading to the multi-threaded lecture. If we look at thread tutorial number 1, we look at the concept of using threads, the approach to threads. And you're like, what do I mean with threads? Java threads are supported, and so is thread programming. So we make a task list with executors.new fixed thread pool. We can make an entire pool of threads. We can add tasks to the list, make them runnable, run them separate. We can have 3 separate classes that implement the runnable API, and the main activity that might implement runnable to make it runnable. What does that mean? Basically, what we can do is inter-process communication and thread organization using Java threads. If you've ever done any thread programming, you know that Java is easier than everybody else. We have synchronize that we could stick on there. We just make it runnable. We just inherit from certain objects, and all of a sudden we have processes that behave amongst themselves quite well. Why do people like threads? 2 or 3 different reasons here. In order to make a service, you got to make a thread. In order to spawn a process off, so a thread is a process. It comes back from Unix. This Android is a Unix environment. So when we make a background process, what we're doing is making a service out of it. The service is going to be our broadcast receiver, or the service is going to go and upload something or download something or do something for us. Services do not have GUI interfaces to them, but they're activities just like anything else, except for they run simultaneously. You say, how do they run simultaneously? They're not owned by activity, their main activity. They get started, and then they just never stop. They just run. And they're running in the background. You can actually take it and do another approach to it. Start and stop it. But for a background thread to act like a service, it generally doesn't have a UI, well, it won't have a UI to it. Generally starts, but it doesn't stop until the app stops. It's controlled by the main app, can't run outside of the app space. So if the main app stops running, the life cycle of that ends, the app goes out of scope, comes out of memory, so does anything associated with it. All right, related topics here. Race conditions, synchronization, helpful thread related, and lucky for you, I'm not going to give you a complete thread overview. Get this if you take the Unix class. Actually, I think I'm teaching Unix next term. If you're taking my Unix class, you'll get everything you wanted to know about threads and multiple threads and processes and stuff. It's really a strong Unix topic. Why do we want to do this in Android? Well, here's our pros. Advantages, even on a single processor system. Multiple threads give us multiple processing, gives us multiple speeds, multiple work can get done simultaneously. That's the only reason why we care about threads in Android. That we can have something running in the background and something running in the foreground. Makes use of our app space more efficiently. So for efficiency, for downloading an image file as an example, which we don't want to do, and the reason why we saw this actually in the last tutorial that we did, we created a thread and had something run, an HTTP request run, doesn't matter if you did the tutorial or even anything about it, in the background so it wouldn't block our UI. So that's another good reason why people like threads. Spawn a thread, create a process, put it out there, let it run. Like downloading an image is a good example of that. Why do you want to download an image in the foreground? The user's going to sit there. I'm going to press a button, download an image, right? You're going to have the foreground thread do it, which is controlling your UI? No. Otherwise, you're going to sit there waiting, 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 still waiting. Instead, it happens in the background. The UI is still responsive. You can still press stuff. You can still do something. A few minutes later, oh, your thread's down. Here you are. Here's your image. Oh, thank you. Or better yet, you're going to design it so it just populates. So your apps that go out and they find music for you, they find pictures for you, they do all sorts of things. They exchange text messages back and forth and stuff, and they do that all in the background. None of it's in the foreground for usability. Doesn't block the UI. So we're trying not to block the UI. Makes it more, when I say that, I'm talking about this, responsiveness. If you block the main thread, event handlers will not respond. So you don't want to block the UI. Efficiency, convenience, clock icon. Have the clock thread run in the background. Put the icon out there. It doesn't take up the entire foreground. It doesn't take up the entire app. Some devices have multiple CPUs or cores. Android devices do. Droid devices are the best one example of this. You can create a pretty sophisticated Droid application that's designed to make use of the multiple processes. What is that going to do? One processor is doing this, another processor is doing that. Multiple threads, multiple distribution of resources, faster processing. So that's where, you know, if you saw it, all those commercials that were out, the bionic droid, you know, all that stuff that came out, it was because of those multiple processors, dual cores, separated dual cores. So programmers could write applications using multiple threads. You don't know how to use a thread, you're not going to write any of these applications or care about it one or the other. Anyway, some devices definitely take advantage of that. You can actually run get runtime.available processors and see how many processors you actually have on your phone. So those were all the pros, and see how big the pro list was. Here's the cons. Significantly harder to debug and maintain than single-threaded apps. Yeah. So this is why I saved this lecture for last. Not the easiest programming technique to look at. Oh, I think Joel wants to do attendance. So let me pause for a second. All right, let's finish this lecture. So this is our last lecture. So steps for concurrent programming. After we've gone through the pros and the cons, and now we're going to look at this. First, we're going to make a task list or a thread pool task list. Here we have an executor service task list. What's that going to be? It's going to be a thread pool. New fixed thread pool with a pool size. Just abstractly, let's just take a look at this, and we'll look at the source code example, and you'll see how it works together. Don't have to program for this for any of the assignments, nor do you really have to know anything about the concept of how to implement this. Nice to know about threads and the capability. This is what I'd call the second semester course. If we were doing a second semester course in Android application development, we would do threads, processes with multi-threaded applications. We might have this course in the future, who knows. We would do APIs with third-party APIs and more cloud. We would do services for cloud file system services and stuff like that, which is higher level, kind of intermediate advanced level stuff. But for a base course in Android, we actually covered everything, seriously, that would be appropriate for like entry level, base level. So maybe in the future we'll have Android application development 2. And the requirement of that course would be to take this one, because I can't take anyone brand new into that class. But I think it would be fun, especially after a couple more semesters. We'll have definitely another couple more groups that go through this, that maybe in the summer I'll be able to offer the part 2 or something. But yeah, threads are something that, it's tricky. It's hard to get it to work, actually, which is the problem. So now after we make the thread pool, and the size of the pool is going to be the maximum number of simultaneous threads that we're going to want to run, what we're going to do then and make it higher, hopefully, than it needs to be, so we have a little spare room in there. And then we're going to make a separate class that implements Runnable that's going to organize our thread pool. So we're going to add the task to the list, 3 options, 3 different ways of doing it, making an instance of the class, starting the thread via the task list, execute. So .execute, if you know anything about Java threads, it's one of the Runnable, implementing Runnable. Runnable's an interface. So execute is sort of like run. .run is to applets and to other types of Java things. So to make something runnable, you're basically making it so it's startable. So implementing Runnable is another interface. So in order to really understand threads, you actually have to understand interfaces, because you're extending classes and you're implementing interfaces. And all of the thread stuff is an interface-oriented thing. So maybe before the second level class, we'll have I'll have Java object-oriented programming in Java is a prerequisite. This class is a prerequisite. Then the advanced class would be appropriate, because really you're doing is taking Java programming to a higher level of implementation for Android. All right, so here's our thread mechanism. Number 1, a separate runnable class. So remember all the methods we did for the event class. We could do a separate class, we could do an inner class, we could do an anonymous class. We could just have a method and just put the method on the class implementation, or excuse me, put the method, write the class and the method and attach it to the listener for the event. We have the same options here. We have 3 different ways of doing it. Here's a separate runnable class. Create a class, we extend runnable, we implement runnable as an interface. We put the actions to perform in the run method. So we have a special method that we're going to do called void run, which is Java. That's core Java. And what does that do? It's kind of like main. It runs whatever code we're supposed to be running in this method or in this class. So class makes the that implements runnable. No import statements needed because it's going to implement this interface. And then we have a run method that we're going to put in there. And then we create instances of your class inside of a main activity. So main activity makes an instance of this class. This class has run method, implements runnable, makes it into, when it starts, it runs in its own thread space, aka its own process. So you're basically spawning a new process through this class. So through the separate runnable class, there's a template of what it might look like, where you've got start some thread as a method that you're going to put inside a main class that extends activity. This is the weird part. It doesn't really matter that this is inside of an Android application. It's the same code. So what a lot of people have done actually is they've taken complicated thread processing code, just extend activity off of main and turn main into a main activity class. Now you have an activity that starts from an Android activity that does everything else in Java that's just like a main activity. So people do client-server programs this way. So you have a phone that talks to another phone as a client and a server kind of framework, or distributed multi-peer-to-peer. So you could send messages back and forth without using SMS or something like that, by having apps that connect to each other through the network over TCP/IP or over even the cellular network actually would work, depending upon what you're doing with it. So you can actually make some pretty interesting networking applications. Threads are used a lot with networking. Threading basic activities would be the main program, and then we have a spool of separate threads that run in there. So just like with the databases, it's nice to have a little helper class. So remember the database components that we put together? We had the database helper. Database helper was responsible for creating the tables and querying the tables and updating them and selecting them and doing all the work that's associated with the database connectivity, and then you include the database helper in each one of your apps that you're creating. If you make the class once, you can just include it over and over again and then use the database helper as your interface into the database. Well, the same concept here with a thread class. So the thread helper, this one's called thread utilities. What is a thread? What is a thread possibly going to do? It's going to stop, start, and pause. So we put a pause in here. You know, what does the database do? Well, it connects, creates tables, deletes tables. So anyway, the thread utility, this one's going to have a pause method in it. Tells the thread to sleep. Why do you want to do that? Maybe it's not working. Maybe it doesn't have to work. But then when you want to download another picture, as an example, you can turn it back on again, unpause it, break it, wait. So if you remember semaphores and mutexes, good old Linux and Unix thread processing, it's the same thing except for Java uses semaphores, no mutexes, and it's all built into the JVM or the Delvic actually in this particular case. And we actually have wrappers on top of it for Android. It makes services out of us if we want. Pros and cons to this particular approach, and the approach they're talking about is just making a separate class, implementing Runnable, creating it as a thread, making an instance of this class in main activity, running it as a separate program. When you do this, there's no intents, there's nothing. It's just one activity, creating a thread and running the thread. Advantages, loose coupling. You can change the pieces independently. Just add another class. Don't make an instance of the thread. It's separatable. Can reuse the Runnable class in more than one application. Passes arguments if you want. Different threads to do different things. You can pass it different information from main. And you can pass arguments to the constructor, which stores them in instances that runs them. And there's a little danger of race conditions. Main activity started it. Main activity can clean it up and start another one or don't start another one. There's a lot more control over it. Usually use this approach when there's no data sharing among the threads, so you don't need to synchronize anything. It's just one extra thread running. Disadvantage, hard to access the main activity. This is what happens in 99.9% of all of these nice little fancy Android games. If you never can get back to the main menu, it's because you got threaded. The main activity spawned a thread, thread's running, and it's lost. It's either the game stopped or the game's got an issue, and you end up having to like reset the whole thing to get out of there. That's the problem with this. There's no control. Parent-child relationship, parent stops, child runs. Same process space. Child doesn't quit successfully, child's hung. Parent's hung too. No getting back. Parent can't call it back, parent's dead, or parent's not dead, parent's paused. Paused in the background. And it's very wasteful. You leave that running, and you start up another instance of that game, or better yet, you just do that a couple times, or you have a couple of crazy apps that you're running that do that constantly. It happens a lot, actually. Then your phone starts running a little sluggish. And then you go, oh, maybe I should reboot this thing. And then don't run those games because you're going to end up having the same problem. It causes a memory leak because the threads are running, the child's running, but the thing hasn't stopped yet. You can't do anything, it's stuck. So if you want to call methods to the main app, you must pass a reference to the main app to the runnable constructor if you can. Or make the method in the main app be public, so you can run it from the child app. So, in either way, there's a little bit of lack of control between it, so it's hard to access it. So approach number 2, the main app implements Runnable. The whole thing's a thread. So instead of having the main app a regular activity and it creates a runnable thread from it, you make the whole thing a thread. So here we have the shape interface, and the shape's got a circle in it. And this is an review of interfaces for the syntax. Okay. We didn't cover interfaces in here, but this is how you use an interface, by the way. It implements something. So if you had a Java background and you were able to do this, you would say extends to inherit, implements to interface to an interface. Some of you have taken the Java class, so you know what I'm talking about. So reviewing the benefits of this, the class can be treated as an interface type. So we have public interface shape. We can put stuff in there. We can add the methods, and we can implement the unimplemented methods to change the behavior. Kind of like the same way we would use an abstract class, actually. So making the main app runnable, we said we have my class extends activity, implements runnable. So the entire app, you could actually do this with any one of the apps that we've done so far. Just adds implements runnable, add a public void method, which means when the instance of that activity gets created, anything in here is going to trigger. Well, that's kind of like the automated behavior you get with the onCreate, actually, because onCreate's actually part of the life cycle. So of the main app thread that runs. Here you're just going to make it runnable, which means you can make more than one. What does that mean? You don't like using intents. Now, think way out of the box and think more advanced from now. You've been using intents for years, you've got everything set correctly, and you think intents is too slow. So you want to improve upon the process. Or you want to have multiple main activities running simultaneously, which is not a bad idea, actually. Then you get the Android system. So Android, when it runs, it's not just one thread that's running. You got a thread that's doing your phone services, you got a thread that's doing your SMS services, you got a thread that's doing your application layer framework, so you can load other apps on top of it. Think of a layered kernel. You have all of these different threads that are running, and then finally you get the user thread. And the user thread is the thread that you're running your applications in. You can actually design your kernel-like kernel inside your kernel. So your app can sort of run like a kernel if you wanted it to. Why do you want that? Maybe you want all of it running simultaneously. You don't want to go from one activity to another activity to another activity. It's the only reason why you're using threads to begin with. You make main activity runnable. It's a separate thread. You can load another 5 or 6 more threads at the same app level. Now your app has got 5 different apps in it all at one time running simultaneously. All you do is switching back and forth. With an intent, you're unloading an activity. In the same, you got your app space. Inside your app space, you're loading up an app. Intent, unload that app, load a new app. Unload that app, load a new app. This threading, simultaneous. Multiple apps running simultaneously inside of your app. Do you really need to do this? Depends on the application you're writing. A lot of games run this way. A lot of game programming runs with threads. Why? Because you got simultaneous speeds of a bunch of stuff. And then you got networking. So you got another component, another user who's coming in from another server from another area who's playing along with you. Like the card games are all multi-threaded apps. Or the fantasy games, or the component level games that run with exterior clients that are out there who are logging into your game, playing all at one time. Some of them are running this way. Not all of them, but some of them are. Alright, so you can pass the instance of the main class to execute here. This task list execute, and the main differences from your previous approach. So it's good. You can easily call methods in the main class because it's not going away, it's still out there. Since it is in that class. It's still there, still available. Bad, if the run accesses any shared data instance variables, you have to worry about conflicts or race conditions. Yeah, you have a multi-threaded application. And you have to worry about race conditions as well as starvation and all of the other inter-process communication problems. Very hard to pass arguments as well. So the task starts off the same. So main app implements runnable. There's a little bit of template code for it. You just make the main app implement runnable instead of creating another class and adding that class in there. And here's our little source code for it. Looks pretty good. And here's our sample output. Looks alright. It's just going to load up thread pools, and it's just basically going to show you. In fact, if you run the app, the code that came down with this, we don't necessarily have to run it. It doesn't do much for us, so I'll run it at the end just to make sure it's the same example I'm thinking of, but I don't think there's very much GUI to it. But we'll take a look. Pros and cons to the approach of making the main activity runnable and putting multiple threads in alongside a main instead of switching back and forth using intents or another technique. Advantages: easy to access the main app. It's still there. And the run method is already inside the main app, so it can access any public or private method or instance. Now take a look at the small little advantage, huge list of disadvantages. So this is actually the opposite in terms of the disadvantages. The other one, just making a runnable class and sticking it inside the app, a lot easier. More advantages to that. Disadvantages: type coupling. Run method tied closely to this application. Yeah, the whole thing has to run together, it won't run. Cannot pass arguments to run. No, it's running at the same time. So either start a single thread only, quite common, or all the threads do very similar tasks. Why do you want to have that? If all your threads are doing the same thing, why have 3 of them, 4 of them, taking up more processing power than worth? Might as well just have one of them do it, because they're not going to do it any faster. Danger of the race condition. 2 threads going to the same piece of information simultaneously going to have a problem. Who's going to get there first is going to be the winner. Winner might not necessarily be doing the desired change that's needed for the app. So something might be overridden while something's being updated simultaneously. Not such a good thing, actually. Alright, or the inner class that implements runnable. So I don't even have to go through this part, I can just tell you. Instead of putting the class as an outer class on the same level, you just put it inside. The other method is to make it anonymous. So if you want, you can actually sort of use this as sort of like the design template Same thing happens with our action listeners and our events. We make it a separate class. We make it an inner class. We make it an anonymous class. Or we just attach it to a method. So we have multiple ways of doing something. So, all right, I'm going to skip through all this stuff because it's kind of dry at this point, because I really wanted to do is just introduce you to the concept. If you put it inside, make it an inner class of an existing class. Advantages, the same thing as you have with the main class. It's easier to access it because it's owned by the main class. Methods of the inner class can be accessed public or private data members because it belongs to it. And you can pass arguments to run it. Disadvantages, the same as you had before. Race conditions and tight coupling. So, alright, so this is the part that goes through race conditions and synchronization. I'm going to sort of skip through this because you don't really need to know any of this. But if you were to take a more advanced course in Android, this is what probably one of the things you would be looking at, actually. In part 2 of the multi-thread, we look at the GUI part of it and updating the GUI. So part 1, if you have an interest in this, go back and read through the parts that I skipped. But part 1 is all to talk about the pools, thread pools, and the use of multiple threads, and whether to make the main activity runnable or make the whole thing runnable, or yada yada yada. Part 2 of this is about the GUI. So it's the GUI update guidelines, GUI threads, updating UI after threads, updating images from the internet, updating the UI with the view post, and similar GUI related things. Because what you're doing with threads is you're trying to not stop the GUI. You're trying to make a seamless user interface where you have processing going on. You have stuff happening, but you're not waiting for it. And it's kind of like the old days when people used to do something on their computer. They type a command, and you wait for the command to execute. That's unheard of. And then you sit there and you stare at the screen while the command is working, and then something comes back and says, hey, we're done. Who does that anymore? That's DOS compared to Windows. Android does that. That's Android. Android runs as a single thread. It starts and it stops, but we don't know that. Unless we start building sophisticated apps and we have stuff going on, the user's not going to sit there. So you've got to constantly take the background threads, update the foreground with it, update the GUI, change the list of files, do all this stuff while the GUI's running. Because you don't want to stop the GUI. If you stop the GUI, you're going to have a problem. When do you have to do anything like this? Well, when you have unresponsive GUIs. You don't want unresponsive GUIs, yeah?
So is it just with respect to the GUI, or like in any Android phone app, there are so many applications running in the background. So are they running on all one single thread?
So back on day 1 of the course, when we go through the Android kernel, each one of your apps
has one JVM.
Runs on one single island of its own. It's a Delvic, actually,
yeah.
DVM, whatever. No, it's like a JVM.
JVM, yeah.
But it's only one thread running at one particular time. And we call these things activities.
Mm-hmm.
And the activity loads up, and then we have intents. And the intents switch everything around. And then we have this manifest that keeps track of everything. Organizes the permissions, organizes which activity is allowed to run, what kind of data can be passed between the different activities.
So that means there can never be a multi-threaded application for the phone.
Yeah, yes, there can. That's what I'm talking about today. Today I'm talking about part 2 of Android development is getting out of that single thread thinking and thinking about multiple threads. So everything in this class we did is a single thread. 99.9% all developers don't even realize that they can do multiple threads. Everybody does single thread. Why are you going to do single thread? Well, 99% of the time, that's all you need. You have an app that comes up with a little screen, you type the screen in, draws up another activity. This activity goes away, this activity stays, you save the data in between the two screens. You keep going from activity to activity. 99% of the time, that works just fine. You build something more sophisticated. You take it past that level of beginner or intermediate. You go into more advanced development techniques. You got to do multi-threading to get the response that you need. How are you going to get an interactive game to work when you got processing that's going around with multiple players in the background, constantly updating the UI. Doesn't work with a single thread. How are you going to get a process to run in the background to perform a service to update the foreground for you? To tell you that you have 5 new messages and you had 3 new voicemail messages, and yeah, so-so is trying to get a hold of you, or keeping track of how long your phone's been up. And so all the services you get on the Android that's built into the kernel itself, multi-threaded. Android's multi-threaded. The apps you're building are single-threaded. It's on a single-thread platform unless you make multiple threads out of it. So each thread of execution from each app is on an island of its own. You still can't go between the islands. You're still stuck within your own process space that's controlled by your manifest. But you can load up many different activities simultaneously by using many different threads. You can also start threads that have no UI. You've ever had one of those apps you just press a button? What happened? Nothing. Doesn't look like anything happened. When you press the app, it just started. Well, why have a button? You're not going to have a button. Instead, you're going to update the system to run it automatically for you. And then you get all the services around that phone. You don't actually have to start your phone services or your SMS services or your instant messaging. You don't have to start any of that stuff. It just starts automatically. It runs automatically. You want to get it, you open up the applications. Populates with all the data that it's been saving. All your new text messages, all your new email messages. Your email is multi-threaded. Pulling stuff in while you're using it. If it sat there and if it froze the UI while you were trying to check your email, you'd have a problem. Because who would use it? But it pulls, and all of a sudden, hey, look, here's a new email. Well, the program was running. There was a thread back there that went and got your email and brought it to the phone, and now it's showing up on your screen.
Okay, so application-wise, it is multi-threaded.
It's one application, but it's multi-threaded. That's a multi-threaded application. You don't have to. You can go throughout your entire programming career without ever creating a multi-threaded app. The same way as you can be an application developer on Unix and Linux and never create a multi-threaded app. Actually, there's a lot of Java developers who've never created a multi-threaded app.
So on the mobile phone, when we have this date and the time facilities.
Services.
Services, yes. We cannot call them applications, right? Because
they are applications.
But then, I mean,
they're background services.
Okay.
And they're part of the content provider system, and we can actually get to it. We can ask the phone, what time are you? What time do you say?
Okay.
How long have you been up? Are you vertical or horizontal right now? We can ask the phone all this stuff. It's in the content provider for the instruments for what's available to you as a programmer. You can make an instance of an object, go out there and say, give me my current position, give me my location, give me all this information. That's running. That doesn't stop running. It's threaded.
Yeah.
All of the Android-based utilities are all threaded applications. Your content provider is running with your app. Your app's running with everybody else's apps. So it is multi-threaded. The phone itself is definitely multi-threaded. The app development environment is on a single-thread model that the programmer has to create multi-threaded with.
Okay, so here the threads are working on multiple applications, not multiple threads within one application.
Nope, it's multiple threads within one single application. You have one application, and you have 5 different threads. You create a thread pool, and you put all the threads inside of the same application. Then you get multi-threaded. Same thing you get with Unix programming, actually. Unix, it's the same thing. They call it multi-programming, multi-threading, well, multi-threading. Fork off another one, fork off another one. Shell. A shell is a multi-threaded program.
Multi-threading is asynchronous?
Asynchronous? No, asynchronous. Depends on your platform.
Yeah, actually.
It depends on your platform. Linux, Unix, it's asynchronous from parent to child relationship. Parent runs, child runs. Only one thread at a time runs on Unix and Linux. Multiple threads can run on Android. Single thread runs on iPhone. iOS, which is the most ironic thing, because when the phones first came out about 5-10 years ago, people go, well, Apple and iOS, that's not multi-threaded. Only one program can run at a time. It's still the case. Does it really matter? It's the thread model. Android is synchronous. Multiple things run simultaneously. iOS is one at a time. It's a different thread model. Same capabilities, same performance level. But people get stuck in their thinking that, oh, yeah, it must not be. It's primitive. It is primitive. iOS is based on old Unix. Unix runs that way. Java runs differently. Android's based on Java. Java runs with an upgraded, newer, synchronous thread. It's why they call it synchronization. The threads are running simultaneously. And the synchronization gets them so that if they happen to be reading the same line of code at the same time or doing something similar and they butt heads, they don't crash. One of them gets to go first, the other one gets to go second, depending upon some sort of synchronization method. Which is why we have synchronization. Don't worry about, this is advanced level. This is beyond the scope of this course. All right, let me just finish this up then. Some people have an interest in this. This is what you're going to get the last lecture of this course. You're going to get something that's too advanced for you. All right, issues. Unresponsive GUI controls. Games. That's why I say games, because games are a high level of interactivity. You got to get responsiveness. When you press a button to shoot something, it's got to shoot it. But if somebody else on another thread is shooting it at the same time, you got to synchronize everything. You got to have responsiveness. Long-running code in the main thread will make the GUI controls unresponsive. Yes, it will. Too much processing will slow down the GUI. Can't do it. Threads cannot update user interfaces. They can't. Background threads are prohibited from updating UI. So then you got an issue with, well, how am I going to control it? So in your unresponsive GUI controls, the problem is also looking at the long-running code. Yada, yada. Here's an example. If a button's on-click handles takes 5 seconds, then none of the other controls will respond for 5 seconds. That's true. You press a button, something happens, takes too long. You're just going to press it a couple times. Actually, we saw that with the EMS on the new online course. I don't know if anyone's in any of the ones that are running right now. They fixed the problem. But the users would sit there and write a discussion post, and then they press post. The post was taking too long. So they'd press it again, and then you get the message posted 3 or 4 times. And then the tech support people come back and say, well, don't tell your students not to press it 5 times or 3 times. I think, well, that's not a good solution. Why don't you pause? If you're really going to pause the UI because your process takes too long, stop the thread. Pause the thread. That way the button's not responsive again. So you press the button once, it waits. And then you press. It's very common with UIs, actually. If the UI takes too long to come back with a response, the user's just going to keep clicking the button. And in the case of the EMS, we get the message posted a dozen times. Whoa. Anyway, long story short, it's a real-life example. So, for the solution, move a time-consuming operation to a background thread. If it's too time-consuming, put it on the background. Don't pause the UI. Or pause the UI if you don't want it to post it 5 times. So there was an entire point of the previous lecture on the basic thread programming was to do that. So threads cannot update the UI. Now, UI is user interface. Threads are background processes. They don't have user interfaces. They have no control on the user foreground. They're background processes. So we can't update the UI. So background thread cannot add a new view to display, nor can they call a text view on a visible view or something of that nature. So that means you can't create a background thread to pull email messages and actually show the email messages. They have to pass the data back and forth because they have no UI associated with them. Solution, wait until all the threads are done, then update the UI. Stop the background, take the information from the background, move it to the foreground, update the UI. And then you got a good one there. And have the background threads also use a view.post to send it as well. You could do it that way. So, all right. I'm not going to go through the rest of this, and there's not too much left of it. Actually, there's a lot, mostly source code of the example I'm going to show you right now. If you're interested in seeing this live, let's take a look here. This is the multi-threaded examples. Let's go see what's in that. There's one that does downloading a web image that's worth looking at. It displays a network image There's a button, you press it, it downloads an image, but it doesn't in the background, so you can see the two work. Actually, let's see if that one is part of this example set, because that's the one I wanted to show you. That's life cycle. In here, this is the zip file that goes along with a tutorial called multi-threading. Let's take a look and see what we have in there. I have to refresh my memory on it. I'm looking for, we did one earlier in the course actually that did not use a background thread, that downloaded an image with a status bar. Downloaded an image from the internet actually. It wasn't tic-tac-toe, it was around there though. It was right before or after the tic-tac-toe. We had a web view that downloaded an image, but it did not use threads. But let me go take a look at this one here and see how similar it is actually. I think it's called download image or image viewer. It might be called image viewer actually. Whoa. Simple image downloader activity.java. Alright, I'm going to start my emulator because I didn't do that. Let's start the emulator. The lecture example is called Simple Image Downloader Activity. That is inside of the, oops, kernel driver not installed. I know. Did I erase my ISO file? Well, I guess this is a good day for it to break. It's the last day of class. This is really weird. Let's just, you know, I upgraded my VirtualBox. Maybe that's a good reason why I shouldn't be updating it in the future. It's having a problem right now, actually. Hello, let's just see if I can kill the VirtualBox. It seems to be a bit hosed right now. Kernel driver not installed. All right, I'm wow. Neither one of them are loading now. All right, well, is the emulator working? You're saying it's not working? I mean, you're saying it is working? No, this one's working. All right, my emulator's not working. Yeah, I don't know what the problem is. I upgraded my VirtualBox and I think I broke something. Is yours working? On the current one? All right, let me try one more thing. Let me close Eclipse, actually.
No, without virtual machine. It's working with inbuilt emulator.
Oh. But I like VirtualBox.
It's fast. It's working. Maybe that's
I know, but my VirtualBox is not working. All right, well, I don't want to load in mine because it doesn't work. Anyway, long story short, what I wanted to show you was this example here. I would probably have the screenshots on it. Here's the screenshots. If you load it up, what you wanted to see was this. You're going to download an image, put it into an image view from a URL. So you type in the URL, you download the image. I don't know if that URL is still working or not. And when you press the download image, there's two versions of it. One of them actually freezes the UI, the other one doesn't. Because one of them puts it in the background, loads it as a background thread. The other one doesn't. The other one just uses a single activity thread. So basically you can see the differences between, why do you not want to pause the GUI? It makes it unresponsive because when you press the button, nothing happens. And the other version of it, you press the button and it sits there and it doesn't, you're not frozen. You can actually click the button again or you can do other stuff. So anyway, I don't know why my emulator's not working, but yeah, but I don't have yours on my projector. So I'm actually kind of wondering what happened with this. Could have been a recent update or something. All right. It doesn't. It'll crash my system. So. The built-in emulator doesn't work on my computer. No, it will work, but long story short, it won't work on my system. Then we have the other one here. There's a couple different versions of it. One of them will actually download it and update it while it's downloading it. So it'll bring the images in one by one. When it gets done loading one in, the background thread pauses, the foreground thread, which is the foreground for the GUI, updates with the new image view. So you'll see 1, 2, 3, 4 get loaded up. So anyway, you don't really need to know this for the final exam. I just thought I would show you the multi-threaded stuff. If you want, go ahead and download and run these examples. I'm not quite sure why my VirtualBox isn't going to work, but it's not going to work. So, oops, now it's going to complain. What is this? Creating process for virtual machine? I don't know. I think I'll leave you with that. My VirtualBox decided not to work anymore. You're right, don't upgrade it. If you get that 3.2 upgrade or whatever that was, don't upgrade it. That's why yours is working. So I'm going to, maybe mine's made for the newer version of the Maverick. And I don't have Mavericks. I don't know. It used to work. I'll leave you with that. And unless we have questions, comments, or concerns, that was a brief introduction to the threading components. Play around with it. You might actually find them interesting. If you download the source code, you don't have to do anything with it. Just import it into Eclipse and start running. There's like 5 to 6 different projects in there. You'll see the screenshots in here will match it and or come similar to it. If the images are gone, put some images out there or find some images on the internet and change the URLs. The idea is that you see the basic UI update or not update, and then the responsiveness and the user experience that's associated with using single threads and then also using multiple threads. And you're supposed to discover that the multiple threads allow you a better user experience. It gives you a better experience. So I will leave you with that. You can take a look at it. And unless we have any questions, comments, or concerns, then I believe we're going to be done for today. Okay. All assignments are due by midnight on Monday the 16th. Anything submitted past Monday the 16th doesn't get in. Don't wait until Monday. Do them Sunday. If you wait until Monday at 11:59 and then you send me an email message that you couldn't get in, I have no mercy for you. Don't wait till 11:59 on Monday night. Do them on Sunday at 11:59 if you'd like. But don't do them on Monday at 11:59 because you're not going to be able to get them updated. Alright, see you next time. Next time is the final. Oh, so for those people who came in late, a couple of people have already asked me, so I'll just repeat it one more time. You don't like Monday? Don't take the exam on Monday. Take the exam on Wednesday. Exam can be taken Monday at 2 o'clock or Wednesday at 11 a.m. If you like Wednesday better, take it Wednesday, 11 a.m. Okay, see you next week.